Hello, and welcome to the webinar today. My name is Carrie Berger, and I'm the coordinator for the Northwest Fire Science Consortium. For those of you who aren't familiar with the consortium, we are one of 15 fire science exchange networks that are funded by the Joint Fire Science Program. Part of our mission is to disseminate regionally relevant information to our stakeholders in Oregon and Washington. And so we try to do this by offering a diversity of opportunities for people to participate in, and hosting webinars is just one way we accomplish that. So to avoid any noise interference, I have muted your audio, so if you have a question, please type it into the chat box. Also, I will be recording the webinar and will archive it on our website and YouTube channels. And so I went ahead and put those web addresses in the chat box for you. I'd like to give a warm welcome to Corey Blankenship. Corey is a fire ecologist with the Nature Conservancy's LANDFIRE team. In her decade plus at the Conservancy, she has facilitated the creation of thousands of vegetation dynamic models for ecosystems across the U.S. and is one of the leaders of the ongoing Biophysical Settings Review and Update project. Her current focus is on applying LANDFIRE products toward addressing land management challenges on large landscapes through data customization, user support, and outreach efforts. So Corey, whenever you're ready, go ahead.
All right. Can you hear me?
I can. You sound great.
Okay, wonderful. Well, thanks everyone for being here. I'm excited to give this webinar to a group in the Northwest. One of the challenges always working in the Northwest, and really it's a blessing, I guess, more than a challenge, but you have a very rich data environment. So you guys have data from the Gradient Nearest Neighbor, or GNN products, the ILAP, or Integrated Landscape Assessment Project, has produced quite a bit of great data for the region. And then, of course, there is good data from the Forest Service and the BLM and smaller units. So LANDFIRE is just one piece of that data landscape, but it's particularly useful at broad scale. So we're going to talk about how it can be used at broad scales and then at finer scales, and how you can review and modify it for those finer scale applications. This is our agenda. I'm going to go over just a little bit of background. I assume that most people are familiar with the LANDFIRE project. If you're not, there's a ton of information online. So I'm just going to give kind of a high-level overview of what LANDFIRE is designed to and why we emphasize reviewing and modifying the data for finer scale applications. We'll briefly look at reasons to modify spatial data, and then I'm going to go through and spend most of our time on the set of examples. I have some examples from around the country, and then we'll end with a more in-depth example from here in Oregon. And then at the very end, we'll briefly cover some of the tools and resources that are available to help you with this kind of review and modification. LANDFIRE produces spatial data wall-to-wall across the country. We are a joint effort between the Forest Service and the Department of Interior. The Nature Conservancy is just a partner on that project. So you can see our mapping teams on the left side of your screen here. Most of those folks are based at the USGS Aeros Data Center in Sioux Falls, South Dakota, and then our little LANDFIRE team there on the right, and we're spread out all across the country. So LANDFIRE produces more than 20 spatial data products. These are 30-meter raster data. They're available online for free, and they cover the entire United States as well as the island territories. And in this list, there are a handful of products that aren't explicitly spatial, but most of these are raster data sets. So most of you, probably are familiar with LANDFIRE, but I want to give kind of a high-level overview that might give you a slightly different perspective on what it is that LANDFIRE is all about. So there are a couple of hallmarks of the LANDFIRE program. One is that we're producing wall-to-wall data regardless of ownership. And not only are we doing that for the entire U.S., we're now doing it for the island territories as well. So that, of course, produces some very powerful data, but you can't map the nation under LANDFIRE's production schedule and budget as accurately as you could map smaller areas. So we're not really a replacement for local data sets. Another hallmark of the LANDFIRE project is that we use consistent methods across the country. So that gives you the ability with our data to compare really disparate areas like Florida to Alaska to Guam. And of course, there's a lot of power in that, but again, it does come with a cost. We sometimes can't take advantage of better local data because we're trying to create this consistent product. A good example of that is in the past, we have not taken advantage of LiDAR data. LiDAR data would probably be a better way for us to map height, vegetation height, but we haven't done it in the past because it's not available nationally. Although we've prototyped some methods, and in our next iteration of LANDFIRE products, we probably will take advantage of it. So sometimes that changes over time. But we know that there are, in some places, better methods or techniques that we could use, but if we can't do it nationally, we can't always take advantage of them. LANDFIRE data are designed with a purpose, and that purpose is to support national level fire prioritization and resource allocation. So with that, we produce this set of data where all the layers combine to achieve that goal. And so you've got this interrelated suite of data where the layers work well together. And for those of you that work with GIS and do GIS analysis, that's a really wonderful thing and relatively hard to come by. Actually, I was just going through email this morning and I read a statistic that GIS analysts spend 60% or more of their time just getting data to the point where they can work with it. So not analysis, just data management. And with LANDFIRE, there's probably some data management that goes on, but not as much as with a lot of other data, or certainly if you're cobbling together multiple data sets. So the fact that we've got all these layers that are working well together is a real benefit. But of course, we can't be all things to all people. If there are issues, fire is generally going to take precedence where there are conflicts. And then LANDFIRE data are updated and improved over time. It's really expensive to keep data up to date, so it's nice to have a national program like LANDFIRE doing that. In addition, every time we remap, we learn more, and we do our best to make improvements and incorporate new techniques over time. But again, getting back to that issue of production and schedule, we're always under a production schedule and don't always have time to incorporate some of the improvements we would like to. So hopefully you can see kind of from this broad overview that LANDFIRE is really good at some things. In particular, the national and regional level planning and prioritization is designed to support, but it's not always going to work at finer scales. And that's really the problem that, sort of the larger problem that we're going to address today, that you've got these great data, but they might not work at the scale you need them. And so there are some tools and techniques you can use to adjust them and make them more useful for your particular purpose or objectives. So this is a guide that Don Helmbrecht with the U.S. Forest Service Teams program and I put together, and it focuses on how you review and modify LANDFIRE data. So some of the examples I'm going to give today come out of that guide, but I'm also highlighting it just as an additional resource that you can go to for more information. The other thing that's nice about this guide is that even if you're just making some simple maps or just want an overview of the data, we give an introduction to each of LANDFIRE's products and kind of in layman's terms do our best to describe how LANDFIRE creates that product, and that gives you a really good understanding of what those data really represent and what they're useful for, and maybe where there are some appropriate uses and perhaps inappropriate uses. By the way, that's available online, and I'm going to mention a handful of resources throughout the presentation, and I didn't want to put up URLs because they're long and nobody could copy them down, so I'm going to show you at the end where you can access some URLs that I've put together from information that I am going to reference throughout this presentation. Okay, so there are a number of reasons why you would want to modify data, and generally they could fit mostly into these three broad reasons. One is that you may want to adjust the scale, and that could be either the accuracy or the resolution of the data. You may want to update for change over time, of course, with disturbances and land use changes. There are all kinds of changes taking place on the landscape that you might need to update for. And then sometimes data aren't necessarily wrong, but they could be a better fit for your local landscape, and so you want to calibrate them. And there are a number of examples that I'll give today where that's the case with LANDFIRE data. Okay, so what do you look for when you do a review? Of course, one of the aspects that you might be looking for is the positional accuracy of the data, and that's whether it's really reflecting the true geographic location of features in space. To be honest, I'm not really aware that there's much that the end user can do about that, so I mention it here to be complete, but I'm actually going to punt on discussing that, and that's what Dawn and I did in the data guide as well. These other items, though, you can do quite a bit about, and so that's where we'll really focus our attention today. There's quite a bit you can do with reviewing and modifying content accuracy. Sometimes we call this thematic agreement. And basically what that means is, does what is mapped on a map agree with what's actually on the ground? So if the map says it's oak woodland, and you go out to that exact spot on the ground, are you going to find an oak woodland on the ground? You also want to take a look at spatial resolution. That, in the case of raster data, like LANDFIRE delivers, is the amount of ground area represented by a pixel. And you can change and modify that if you need to meet or better meet your objectives. You want to take a look at thematic resolution when you're reviewing data. That is the level of detail in the mapped classes. So for example, on an NLCD map, you might find a really broad forest class, whereas in LANDFIRE, we have probably over 100 forest classes. So quite a bit more thematic resolution in a LANDFIRE map versus an NLCD map. But you may or may not need that resolution. So you want to take a look and assess what you need to achieve your objectives. You can also review the temporal resolution, which is how current are the data, and have there been changes since the map was developed. And we'll have a couple of really good examples of reviewing and modifying temporal resolution from this Oregon example that I'll give at the end. Now, what you want to keep in mind with all review is that the goal is to decide if the data are good enough to meet your objectives. And then if not, where are you going to make changes? So I encourage people not to think about making perfect data or even calling it accurate data, but just, is it going to meet your objectives? Because it takes some time and some resources to do this kind of modification, and I think a lot of it is quite doable, but I think it helps to frame it in terms of what you really need to achieve the type of analysis that you're looking to do. Okay, so now we're just going to walk through some examples of how you would review these particular elements of spatial data. The first one is thematic agreement, and I like to start with this because I think it is a very relatively easy thing for folks to do and can really improve the data set. So this is an example where a colleague of mine, Randy Swati, worked with some partners on the Hiawatha National Forest. They were trying to compare a LANDFIRE biophysical settings map with a local ecological land type map. That ecological land type map really met the needs on forest lands, but it didn't cover any of the surrounding private land. So their goal was to compare the two maps and determine if LANDFIRE's CPS map could be used outside of the forest boundaries. They did this qualitative comparison by overlaying the ecological land type and the biophysical settings map, and then evaluating the combinations they found using the three-class system that you see on the right column here with that match evaluation. So you've got your ecological land type starting on the left, what it was overlaid with spatially in the middle in terms of the LANDFIRE biophysical settings product, and then how good was that match? So yes, the types were an exact match, or somewhat they matched partially. They had at least some dominant indicator species and edaphic factors that were similar, or no, they just didn't match. And what I really like about this evaluation is that they use this somewhat category. And I think that's important because it shows that crosswalking data is not always straightforward. ecological land type and biophysical settings are not identical vegetation concepts, for one. So while it sounds kind of straightforward, in practice, crosswalking data can be a little bit difficult. Now, in some cases, these distinctions will matter more than others. For example, the mismatch between the acid and the alkaline wetlands might be okay for certain applications, but then it might really be a showstopper for others. So again, that's where your objectives come into play in determining whether that matters and whether you want to do anything about it or not. Now, after making the comparison on the spreadsheet, which I showed on the previous slide, they actually mapped their match evaluation column so that they could see spatially how that played out on the landscape. It's important to note that neither map is necessarily right here. They both have their strengths and weaknesses, but in this case, the local forest folks really had higher confidence in their ecological land type map, so they generally assumed that that was going to be accurate, and if LANDFIRE differed, it was probably not right. Now, as a result of this evaluation, the forest team was able to determine that the biophysical settings map was probably adequate for non-forest lands, and they also were able to prioritize some specific classes and geographies where they wanted to make improvements to that biophysical settings data. For example, they felt like LANDFIRE in general did not do a great job of mapping the wetlands. They had a hard time, or we, LANDFIRE, had a hard time distinguishing the acid versus the alkaline soils. Okay, and I don't have a lot to say about assessing agreement in the field, but of course it really is the gold standard. If you're working at smaller areas and have the ability to do this, it's the best way to go, but it's often not possible. So, but I just want to include it because it is a great way to assess data by getting out in the field and taking a look at your map. Another way to look at thematic agreement, or that falls under kind of the broad category of thematic agreement, is rule set calibration. Some data sets are created by combining other data and then applying a rule set to classify it. LANDFIRE has a couple of good examples of this. One is the fire behavior fuel model data layer, and the other is the succession class layer. They're made from multiple data sets with a set of rules that's applied to classify different combinations of the inputs. The graphic I have here is a schematic to show how we map succession class. It's based on a combination of cover, life form, and height. So in this particular forest example, if we've mapped 0 to 20% tree cover, less than 5 meters in height, we're going to call that early cereal. Now, a couple of things you want to look out for in these kind of data sets. One is that errors compound. So when you're combining 3 or more input data sets, you're sort of inheriting the errors in those data sets. And really, if you're going to review a data set like this, whether it's succession class or the fire behavior fuel models, you really need to go back to these input data to evaluate it. Another thing just specific to LANDFIRE is that the rule sets that create these data are made for fairly large geographies, for map zones, and they might not be appropriate at finer scales, and so local review and calibration is a good idea. Okay, let's talk a little bit about dealing with spatial resolution. LANDFIRE data are 30 meter. And of course, you can resample that data and change the raster resolution. Or if you're working with polygon data, you can dissolve polygons. That sometimes is a better level to work at. For example, I have some colleagues that will do national level analyses, and they resample the data to 270 meters. There are some real benefits to decreasing the resolution. If it will meet your needs, you can reduce the processing time for really computationally intensive analyses, for example, at a national scale. You can decrease your file storage space requirements, and you can speed up the display time. For a LANDFIRE map, one of the nice things is that LANDFIRE maps sometimes look sort of pixelated, and if you resample and decrease the resolution, you sort of smooth that out and get rid of that pixelated look by absorbing isolated cells into larger patches. You can go the other way and increase resolution, but unless you have finer level data to do that with, you're not really going to get improved map detail. So you're generally safer if you want to decrease resolution, but it takes a little bit more work to increase the resolution. Okay, so let's look then at the attributes of a data set. And raster data, of course, have the value attribute table that comes with them. LANDFIRE's attribute tables usually have quite a bit of information in them. What I've shown here, and I know it's a little hard to read, I've taken out some of the information just to simplify it so that it's easier to see on the screen. This is the attribute table from LANDFIRE's existing vegetation type map. And you can see there are a number of attributes to choose from. The primary one is the existing vegetation type name, but you could, if it was a better fit, you could just use life form, or you might look at the Society of Foresters classification or Society of Range Management. We've also got a crosswalk in there to the NVCS, which might be useful. So you don't have to be stuck with that primary attribute. And the other thing you can do besides just choosing a different level of attribution, you could come up with some hybrid on your own where you might lump types together. For example, in this little bit of an attribute table that you see here, the first 3 rows are all for some type of Acadian low elevation forest. If you don't care whether that's hardwood or spruce hardwood, you could maybe lump those 3 together and call it just Acadian low elevation forest. So there's a lot you can do here to adjust resolution if you want to. Again, generally in the level of getting coarser or decreasing resolution rather than going to finer resolution. Okay, and I'm going to give an example from the Sierra Nevada. This is a project that the Nature Conservancy partnered on and with a local collaborative group there. A colleague of mine at the Conservancy and I came in and did a little bit of work to support them in terms of just GIS analysis. So in this particular area, they were looking at the effects of climate change. Most of the analysis area is on Forest Service land, and you can see that in the green areas on this map here. The Forest Service had really good data for those lands, but they didn't have data outside of those lands. And so that's where LANDFIRE came in, and they used LANDFIRE data to fill in those gaps. So the first thing they did was this crosswalk to crosswalk the LANDFIRE biophysical settings into the U.S. Forest Service types. And that gave us a unified legend to work with across the landscape. Now, the second thing we did was local review indicated that wet meadows, which was a really important class for them, were not very well mapped by the Forest Service or LANDFIRE. So they wanted to get a finer resolution wet meadow map. So this actually is kind of an example of increasing rather than decreasing resolution. But to do that, we had to get another data set, and we used the National Wetlands Inventory in this state, or in this case. So we took NWI data and we extracted what we felt like represented wet meadows, and we stamped that on top of LANDFIRE's biophysical settings and actually on top of the Forest Service land as well. So in the end, we merged these 3 data sets together. There's the LANDFIRE biophysical settings, the forest type, which took precedence over that where it existed, and then wetlands took precedence over everything where they were mapped. So the result was this continuous map for the entire analysis area with a unified legend and what they felt like was a reasonable mapping of the wet meadows. Okay, now let's get into this Rogue River example, and I'm going to spend a little bit more time on this. This is my last example, but it illustrates a lot of the points that we've already talked about, as well as just being located right here in the Northwest. This is an example that's in the data guide that I referred to. It's a project that was undertaken by the Southern Oregon Forest Restoration Collaborative. They did a rogue basin-wide forest restoration strategy, and they brought in Don Helmbrecht from the Enterprise program, and he did some work on the fuels layers for them and the fire behavior analysis. Unfortunately, Don couldn't be here today, so I'm going to do my best to give you an overview of what they did, and then I have some additional resources I can refer you to if there are any questions that I'm unable to answer. The goal of this project, the larger project, was to do both a wildfire risk assessment and an ecological restoration needs assessment. And the part I'm going to talk about today is just the review and modification of the data that fed into the wildfire risk assessment. The project area itself was 4.6 million acres and was centered on the Rogue Basin. Now, LANDFIRE data were used for the fire behavior modeling portion of this, and part of the reason for that is, as you can see here, the wildfire simulation area represented by this red box was quite extensive. It was over 12.8 million acres. They needed to simulate fire on this larger landscape because they were looking at large wildfires, and they needed them to be able to burn in and out of the actual project area. So they obtained data from LANDFIRE. They got the surface fuels, information on the canopy fuels, as well as the topography layers. And then, again, because LANDFIRE maps fuel models based on a set of additional input data, they had to get these extra data sets shown here on the right: the existing vegetation type, cover height, biophysical setting, and disturbance. So just as I talked about with that succession class example earlier, the fuel models are mapped using a rule-based approach where they look at combinations of these data sets listed on the right and then classify them into fire behavior fuel models. The disturbance layer is used just for updating data. So if there's been a disturbance over time, you need to factor that in when picking your fuel model. The overall question here was, would the LANDFIRE data be appropriate for simulating wildfire behavior across the study area? So as they reviewed these layers, that's what they were really focused on. And they found a number of issues that they wanted to adjust. The first one was they got out in the field and the local folks indicated that the oak woodlands were really undermapped. So they took that gradient nearest neighbor GNN data produced out of OSU, and they took their mapping of oak woodlands and stamped that on top of the LANDFIRE existing vegetation type map. Now, for consistency, since we had undermapped this type, they were also sort of skeptical of the canopy cover and height at those same locations. And so for consistency, they also used the GNN canopy cover and height in the areas where those woodlands occurred. So that was their first update. Then they started looking at the disturbance data. This analysis, or this part of the project, began in January of 2015. At that time, the most recent LANDFIRE version was the LANDFIRE 2012 data. So that meant that they were already 2 years out of date when they got started. So they looked at what had changed on the landscape. They went to Ravage, the Rapid Assessment of Vegetation Conditions After Wildfire, and they got information about large fires. They found about 200,000 acres of wildfire in the area. And then from local information, they were able to discern that about 11,500 acres of mechanical disturbance had occurred. They also got information on small wildfires, prescribed burns, and some of the management activities from the local Bureau of Land Management, Forest Service, and Nature Conservancy. So they took all those sources of information and used them to update LANDFIRE's 2012 map. The 2012 map kind of served as the base, and they added this additional information they were able to gather to create a 2014 disturbance map. Now, taking a closer look at the disturbance data, they found another issue that they wanted to address. And that had to do with the way some of the silvicultural treatments were classified. You can see on this map that there are two kinds of mechanical treatments, that sort of broad categories for mechanical treatments that LANDFIRE uses. One is mechanical add, where the biomass is left on the site, and the other is mechanical remove, where that biomass is removed somehow, either, perhaps by pile burning, something like that. So when they looked at this map, you can see that a lot of the area, it's a little hard to tell, it's these yellow pixels, so you can kind of see them scattered throughout this study area. But the local folks indicated that most of the time, not always, but most of the time after treatment, the biomass was left on site, and therefore a lot of this should have probably been labeled as mechanical add. If there had been a removal, that would be identified in a subsequent overlapping polygon or treatment polygon where there was a removal treatment like pile burning. So Dawn was able to update this given the local information in a GIS. And again, just kind of going back to the big picture here, the reason they spent the time and effort on the disturbance grid is because that's one of the variables used in the fuel model mapping rule set. So that's why they really wanted to get these things right. Okay, another final issue with this disturbance grid was that there were some mastication treatments in the area, and local reviewers indicated that really neither mechanical add nor mechanical remove was a good fit for these masticated treatments. They felt like they represented a unique fuel structure, and when they got to the point of selecting a fire behavior fuel model for a masticated treatment, they really wanted to know that it was actually a masticated treatment and not some other kind of treatment, so that they could choose an appropriate fire behavior fuel model. So again, in a GIS, Dawn just separated out masticated fuel treatments as their own class so that they could be considered separately. Okay, and then the final part of sort of the preparation, really, that went into critiquing the fuel models was they looked at what map zones intersected the area. This is important because LANDFIRE fire behavior fuel model rules can be different zone to zone. They were created zone by zone by experts, and they're designed to represent conditions across each zone. But you can have situations where the same existing vegetation type has a different set of fire behavior fuel model rules than an adjacent zone. So when you're working in an area that crosses multiple zones, you need to consider that. For this particular analysis, participants decided that they wanted their fuel model rules to be consistent regardless of zone. So Dawn went in and applied a consistent rule set across the whole area. And he did that with something called the LANDFIRE Total Fuel Change Tool, which we're going to talk about here. Okay, so after all of those sort of edits and updates, they got to the fuel rules critique. And this is where they took a look at the rule sets and tried to make the best choice for the fire behavior fuel model for their area. They did this in ArcMap using something called the LANDFIRE Total Fuel Change Tool. That's an add-in that LANDFIRE developed, and it's available for anyone to use. You can download it online. And what it does is it gives you or the user an interface to see the rules by which the fuel models are mapped, and then to easily adjust them and create new layers. So in this environment, the workshop participants critiqued the mapping rules and made adjustments. So as you can see on the screen here, this is the user interface for the LANDFIRE Total Fuel Change Tool. And you can see those variables that go into determining your fuel model. You've got cover, you've got a range of heights, you've got a biophysical setting. In this case, it says any. That variable is not used very often, but it can be. And then the resulting fire behavior fuel model in the Scott and Bergen set. And you can change that right in this interface. And then as you go to the right, you can see that there are adjustments that can be made to the canopy fuel assignments. Okay, so based on all that work, they were able to, using the LANDFIRE Total Fuel Change Tool, create a circa 2015 landscape, and that landscape incorporated the edits they did to the disturbance data, the edits they did to the existing vegetation type, cover, and height, where they added in and accounted for those oak woodlands, and then the calibration they did to the fuel model mapping goals. So their last step was actually to use this landscape to run a few basic fire behavior simulations to see if there were any other issues that they had missed during their calibration. So you can see in this example, they really, I think, spent a fair amount of time and effort updating their data, but in the end, people felt like they had some ownership over the data and they had higher confidence in the results. So then, as I said kind of at the beginning, this was just one part of this analysis, and they took these modified data layers that were calibrated for their local area and then used that to assess wildfire hazard in the Rogue Basin. And this is kind of beyond the example here today, but I'll just briefly show you where these updated and improved data went. Because they didn't just, take all this time and effort just to have better data. What they really wanted was a better analysis of wildfire risk. So the first thing they did was they used FSIM, the large fire simulator, and came up with an annual burn probability map. And then they also looked at community risk across the basin, summarized up to the watershed level. And they used this to guide fuel treatments to areas that they felt like, or their analysis showed, were more prone to experiencing wildfire that could cause damage to communities. So that was the ultimate purpose of all that effort going into updating and locally calibrating the fuel data. All right. If you are interested in data modification, review, and critique, there are a number of resources out there, and I will point to these URLs here in just a minute when we wrap up the presentation. The Modifying Data Guide, of course, from Don Helmbrecht and I. There's another tutorial that provides step-by-step instructions for updating fuel data. If you have a situation where you have large wildfires come through, there's a process in place for updating your fuel data accordingly. We also have some resources on the LANDFIRE YouTube channel, and then of course, as I mentioned, that LANDFIRE Total Fuel Change tool is an ARC add-in specifically designed to help you critique and edit the LANDFIRE fuel rules and then create new layers based on your edits. Okay, a couple closing thoughts here. First, it's important to budget time for review, no matter what data you're using. It does take some time, but it can have a big payoff in the end in terms of higher quality results and more buy-in from those who are using your analyses or data. Another one is that it's important to really understand your needs, because that's going to help you determine what kind of edits you need to do to your data to make it useful for your particular analysis. It's always good to engage subject matter experts. As you saw with that Rogue example, there was a group of local experts that Don worked with that provided feedback. I like to think of data review and modification as a team sport. There aren't that many people that have all the skills necessary to do this, because it requires typically some intermediate GIS skills. It requires knowledge of the ecology, in some cases knowledge of fire behavior, and so you might not find that all in one person. So engaging local experts as needed is really helpful. Balance the trade-offs between accuracy and effort. So it does take time to do this kind of modification, and anything you can do to prioritize your effort is usually beneficial. And then, of course, documenting and sharing your findings, especially kind of within the context of providing an appropriate interpretation of your results. So data are never going to be perfect. That will always have strengths and weaknesses, and that's going to impact how you want to frame your results. All right, if you do get to review LANDFIRE data, we really appreciate any feedback that you would like to provide. A good way to do that is by contacting our help desk. And also there are a couple of websites where you can have input on the products. There's a product review website, which allows you to give feedback on the spatial data, and then of course the biophysical settings review website. And again, I'll have links for these. You can also contact me at any time if you have questions or concerns, and if I can't help you, I can get you to someone else in the LANDFIRE program who can. And so just to wrap up here, there are a number of ways you can reach us online. Landfire.gov is a great sort of one-stop shopping for all of the data. The Nature Conservancy's LANDFIRE page on Conservation Gateway has a lot of resources about how the data are applied, as well as a bibliography where LANDFIRE data have been used. We're on Twitter and YouTube. You can opt into our bulletins or reach us via email. And so I am going to, again, show you these URLs as well as other ones mentioned in the presentation so you don't have to scribble these down right here. So let me see if I can share my internet. There we go. All right. So if you go to the Northwest Fire Science Consortium page for this particular webinar, Carrie has kindly loaded in this sheet down here with modifying data links. And so there's a Word doc there with, I think, all the resources I mentioned, and of course you can contact me if there's something that I missed. All right, so I'll go back to the PowerPoint, hopefully, and I'd be happy to take any questions. I think Carrie will moderate that for us.
Yeah, thank you, Corey. That was fantastic, and you offer so many great resources. So, you know, make sure you check out on our homepage, the Northwest Fire Science Consortium, that list of links, and then also if you're scribbling away trying to copy these addresses for the LANDFIRE Online, this webinar has been recorded, so you can always go back and check out those links if you can't capture everything. But thank you, Corey. That was, like I said, fantastic. There's a lot of good stuff available to folks. Does anybody have any questions for Corey while we have her online here? I haven't seen anything come through. I'm just checking all of the possible. Just give folks a couple minutes to type in. Okay. Well, I actually am not seeing anything coming through in the chat window. You know, and like I said, there are plenty of resources out there. There's a plethora of ways that you can get a hold of the LANDFIRE folks, and then also all the information she listed today will be on our website, as well as the archived webinar will be available in the next couple of days if you want to refer back to this webinar. Well, thanks again, Corey, for talking with us, and I also want to thank you all for taking time out of your busy schedules to listen in today. If you have an interesting idea for a webinar, please don't hesitate to get a hold of us. So have a great day, everybody, and thanks again. Thank you, Corey. Thank you.
Thanks, Carrie. Thanks, Corey.
Thank you, Jeannie.